and so here we go. I had to delete a few things, and we're going to finish this problem. Anyways, so I changed this to an improper fraction, and so 2 times 36, 30 and 30 is 60, and then another 6 and 6 is 12, so that's 72. So 2 times 36, 72 plus 1 is 73, and that's going to be, I'm going to change that to 73 halves. Okay, and the easiest way to change this or represent this as a fraction is to make it over 1. 2 over 1. Just like that. That's what this value is, and I can't change the value. I can change how I represent it, but I can't change the value. Alright, so now I've got this 73 halves divided by 2 firsts, or 2 over 1. Now, I never divide fractions. I multiply reciprocals. Now, I reciprocate this second fraction here. So, does anybody remember what we called this one? Okay. Is it the dividend, the divisor, or the quotient? Right here. Here it is, the dividend. This divided by this, the divisor. The quotient is the answer. 73 halves times 1/2. Oh, look at that. I end up multiplying by 1/2. So I think the other day I mentioned something about when I divide by 2 or I multiply by 1/2, it's the same thing. So then I just do 1 times 73, 73, 2 times 2, 4. And then you should all know how to finish that right there, because I just read my fraction. 73 divided by 4. And I can go anywhere over here. 73 divided by 4. 4 goes into 7 one time. And then 1 times 4 is 4. 4, 5, 6, 7. I subtract. That's 3. I bring down the other 3. 4 goes into 33 now. Oh, how many times is that? 6 times 4 is 24. Okay, so 6 times 4 is 24. 7 times 4 is 28. 8 times 4, 32. Look there, 8. 8 times 4 is 32. I subtract, I get 1, and that's my remainder because I have nothing more to bring down. Okay, I've no more numbers to fill in up here, so I have 1/4. 18 inches and 1/4 of it. So it's 18 and 1/4 inches. So the distance that I needed to go right there between those two boards, that front board and that back board, was 18 and 1/4 inch for this distance here, and 18 and 1/4 for this distance here. And then I could put that board right there. Okay, so I got another math problem. Good, I hope that worked out. Make sure you got that, and you can double check that by rearranging your fact families and see if you can come back up with the total distance. Anyways, you could do that. I'm going to do another one, but I'm going to do it somewhere over here because I do have some problems over here somewhere. But let's just say on this board, let's say on this back wall. So here's a word problem. On this back wall, if you'll notice, I have 1, 2, 3, 4 horizontal boards here that I have screwed all of the metal siding into those boards. Oh, but I have this bottom one too. So I have 1, 2, 3, 4, 5 sets of horizontal boards. And let's pretend that I want to put a screw every 5 1/4 inch to hold the metal siding onto the wood. So it's going to be one, two. I'm going to find out how many screws I need for 6 lengths of horizontal boards. So I want you guys to try this. Okay, I'll come up with an answer. I'll give you an answer on another video. But let's say I have 30 feet. I want to go 5 1/4 inch. Okay. And I want to do that for 30 feet. Okay. Okay. So, 30 feet. 30 feet. First of all, is how many inches? Okay, so I have to figure out how many inches. Okay, and then with the once I get the how many total inches there are, I can divide that by 5 1/4. So I will end up with X number of inches divided by 5 1/4. Now that'll get me the number of screws. We'll call that A. That'll give me the number of screws I need for one board. But then I'm going to need to multiply that by 5. So then it's going to have to be A times 5. So there's your problem. Okay, so here's your information. 5 1/4 inches. Every 5 1/4 inch, I'm going to put a screw. For 30 feet. How many inches is 30 feet? And then I have to work out my problem. I'll let you guys have at it, and I'll give you an answer another time in another video. All right, we'll talk to you later. Bye.